All right, hello friends. Let's talk about branches today. It's a very exciting and useful topic, I think. So I've got a bunch of examples as usual for you that I'm just going to throw out, and that's all in the hopes that something will stick in your brain. All right, I'm not asking you to memorize any of this stuff. You can always come back to the lectures. Remember, I'm giving you all this code, so don't worry. I just got a bunch of examples, and I'm trying to get you to think like a computer. That's the end goal. Okay, so do not fret, do not worry. Let's get started. All right, I do want to remind you that these text editors that you've been using, there is one that's much better than the other. All right, so if you're still using Nano, I want you to do the Vim tutor. All right, please, please, please try out that Vim tutor. It makes your life so much easier on the server. If I can spell as I talk. Vim is the much better editor compared to Nano, I promise. There's also Emacs. Let me know if you want to try out that one and it's not already installed. So Nano is a crutch. I promise you that Vim is much, much better. All right. There's also Visual Studio Code that I'd be happy to teach you how to use, but I do want you to learn Vim at least for the street cred. Okay. So there's that. And then also, as you're using the terminal, you might wonder if there are other ways to use the commands that I've taught you. And so if you would like, I encourage you to look up the terminal commands that you've been using in the manual. There's a command called man, and then you give a space and you say the name of the command you'd like to look up in the manual. All right, so for example, man ls. Like, okay, what is ls? It stands for list directory contents, and you see like how you can use it. It does things, it has some options. ls-a, interesting. ls- I'm just trying to show you ones that I know. ls-l. Here's normal ls. ls-a though, ooh. There's the secret hidden directories, ... and current directory. Interesting. -a stands for everything. All, show all the hidden files, and then ls-l. Let me go out. So here's normal ls. ls-l shows you some extra information that is useful. So let's go back into this, and then you can look anything up in the man pages. So man G++. This is a very, very long manual page. Look at all these options you can give to G++. But you could read this. All right. So encourage you to look up your programs in the manual. Man Nano, man Vim, even. That's a thing. Okay. So yeah, let's get into today now. So I want to talk about how to make decisions in code. Okay, because let me try to motivate this. Wouldn't it be nice if we could have our programs branch off? All right, I want some options, because right now this is what our programs look like. It's like, all right, do thing A, semicolon, then do thing B, then do thing C, in that exact order, right? So if I were to draw a flowchart, this is a technical term, a flowchart form for how this program is going to run, it's first going to do thing A, then it's going to do thing B, and then it's going to do thing C right after that. All right, that's all you get. Wouldn't it be cool if we could like do something like that, right? Go off and do something one way or another way. Wouldn't that be cool? So that's where we're going right now. All right, so to motivate that, we can't do this right now. We have no way of printing, like if they give us a number, we have no way of printing even if that number was even, or odd if that number was odd. Isn't that weird? So like we want to be able to do the following, right? Like we want to get a number from the user, let's call it x. We want to ask like, hey, is x even? Oops, is x even? Question mark. And then depending on the answer, like if the answer is yes, we'd like to print out even, right? Print even back to the user. If it's not even, the answer is no, then we'll print like odd or something. It's like one thing or another thing. We can't split off like this and then maybe come back and do normal straight line stuff later. We don't have that ability. The closest we can do is like we could cheat. We can do something like this and be like, get a number with cin, and then we could print out, we can't print out even or odd, but we could print 0 or 1, right? We can do like x mod 2. We can print that, 0 if it's even, 1 if it's odd, and that's straight line code, but we have no way of printing even or odd the words. That seems like something we should be able to do, right? So let's make that happen. Let me teach you how. All right, so here's my silly example to show you the new syntax. This is from the movie Mean Girls, the classic. All right, so there's a phrase in that movie. If you haven't seen it, please go watch it. It's on Wednesdays we wear pink. All right, so that's a theme. And so I'm going to make a program that asks us if today is Wednesday. all right? And this is what I'm going to do. Is today Wednesday? We're going to ask that to the user. And if it is Wednesday, then we are going to tell the user you have to wear pink, because like that's the rule from the movie, all right? But if it's not Wednesday, we'll tell them that you can't wear pink, all right? So that's what I want. And so based on this question, I want to do one thing or another, and the way that I get that ability is through something called an if-else statement, all right? That lets us branch off in that way based on the result of what's called a Boolean expression, all right? So a Boolean expression is the yes or the no inside of a computer, all right? It is something that becomes either true or false, all right? That's what yes and no mean in computer science. So instead of yes, we say true, and instead of no, we say false in computer science. All right, so is today Wednesday? If that's a true statement, then we'll say wear pink. If it's a false statement, we'll say don't wear pink. All right, so a Boolean expression will become true or false. I'll give you some examples of that soon. And this is going to be what the code looks like. All right, so you say if, and then between parentheses, you put your Boolean expression, the thing that's either going to become true or false. All right, so like this is where you ask your question, is today Wednesday? And if it's true, if that expression evaluates to true, it'll run everything between these curly braces, which is what we want, like we'll print wear pink. And then you put in else, and then some more curly braces. And if this becomes false, if it evaluates to false, then we're going to skip over this thing and go straight to here and run all this code instead. Okay? So I hope you can kind of see how it's going to do the branching that way. But I need to teach you like what could go here. Like how do we make something that becomes true or false? How do we ask questions? And those we get from relational operators, all right? So these are your relational operators in C++. You have this one, double equals, that checks for equality, all right? So you put two things on both sides of the double equals. It can't be single equals because we have that one in use already. That's going to like assign to a variable. So it's double equals to check for equality. And C++ gives back true or false depending on if the numbers are equal or not. So if you say, hey, C++, is 2 equals 2, like what is that? What does that evaluate to? It'll do the check and it's like, yeah, that's true. The answer is yes, those are equal. Does that make sense? And so 2 equals 3, that would give back false, for example, right? Something like that. I hope that makes sense because that's the answer is no. All right, so true is yes, false is no. The not equals, that's how you pronounce it. The exclamation point, you read it as not, and this is the not equals to operator. So that gives back true if the two numbers on each side are not the same. All right, so is 4 not equal to 7? The answer is yes, so C++ will give back true in that case. Does that make sense? That's the secret there. So those are your relational operators for equality, and then you have the others for just like less than, greater than. It's very hard to type this symbol inside of a computer. And so instead of less than or equal to like that, they just do less than sign and then an equals to sign to mean less than or equal to. Same for the greater than or equal to. And so like, all right, 2 less than 3, C++ evaluates that to true. It gives back true because the answer is yes, right? Is 2 greater than 3? The answer is no, so false. All right, that gives back false. Is 2 less than or equal to 2? Yes, it's true. Is 3 greater than or equal to negative 42? Yes, so C++ gives back true. It evaluates it to true. Is 3 greater than or equal to 5? Answer is no, so it results in false. All right, and so you use that together. You place those kinds of operations inside of this part of your if-else statement, and then it will run. All right, so for example, if you say this, if 2 is equal to 2, and then you put some code here, and then you say else, more curly braces, you put some code here, this is the one that's getting run, right? Because 2 equals 2 is true, right? And so it's going to run the true part. It's going to run this code as part of the if. Okay, so that's the code that gets run when it's true, and it will skip over the else part because 2 equals 2 is always going to be true. It's never going to be false. Only if it were false would it go down here. Okay, so that plus relational operators gives us the ability to make this program. All right, so let's make it now. So what we're going to do is we're going to get input from the user, like we'll get the name of the current day, and then we'll check, is it Wednesday or not? All right, based on the answer, we'll tell the user you should wear pink or you shouldn't wear pink, just like in the movie, and then that'll be it. All right, so let me show that to you. Let's make a new file, ifelse.cpp. And so here we're going to need strings, right, for the day. So I'll include the string library. And I just need one word so I can read a string with cn. All right, so I'll make a variable called today, and I'll ask the user, enter what day it is. Colon space, and then I'll get it with CN because every day is just one word. So I have what today is, all right, and now I want to check, like, is today equal to Wednesday? If it is, print pink, otherwise print no pink. And so it's going to be if, and then our check's going here, and then what to do if it's true, what to do if it's false. Okay, so if today is equal to Wednesday, then what do I want to do? I want to print where pink, because that'll get run if it's true. Else, otherwise, what I want to do if this is false, if this is a non-true statement, if the answer is no, I'll say don't wear pink. Yeah? And that's the secret. So once it picks one side, either this thing is true or false, and so if it's true, it runs this guy, if it's false, it runs this guy, and then once it's picked a side and ran it completely, this whole if-else is done, all right? And then it comes back down to the normal code down here, all right? So you can put more straight line code here. ... So let's print something. This will always get run after the if-else is taken over. We'll just like print done or something. So I hope you can kind of see how this program corresponds to this diagram, all right? This flowchart diagram. That's going to be important. So enter what day it is. Let's say it is Wednesday. Wednesday. Hit enter, and you see how, all right, today now holds Wednesday. And so it checks, like, is Wednesday equal to Wednesday? Sure is. So it will run the true part of the if-else. And so it says where pink. And then because it picked that side, it does not run the else side. The whole thing's done. And then it comes down to this code. Print's done. So it's where pink done. Okay? If it's not Wednesday, if it's like Tuesday, hit enter. Then it'll check, hey, is Tuesday equal to Wednesday? Of course the answer is no, so false. It skips over this part, and it goes straight to the else, and it runs all the code there. So it says, don't wear pink. And after it's picked the side to go down and finished it, the whole if-else is over. It's always one side or the other, and then it goes back to the rest of the code down here. So it's don't wear pink and then done. Okay? And you can have many more things down here. So that's our first taste of branching. All right? Please yell at me if you have any questions about this stuff. But I do have more examples today. So that's our first one, though. That's pretty cool. And now we might as well do what we set out to do. Let's do the even-odd example now, okay? So let's see. How do I want to do this? I'll also teach you some terms based on this. So, all right, if I want to get a number from the user, right? My goal is this, right? Get a number for the user, check if it's even or odd, and print if it is. So we want to get the input. And then what do we want to do with it? Like, what's the condition? What's the question that we ask? We want to check if the number that we are given is even, right? Check if the number we're given is even. How do we do that? What's the check? It's this thing, right? It's the mod 2. All right, so let's think about this. If we are given an even number, like 42, how do we know that it's even? By doing mod 2. Like, that does division and gives you the remainder, right? So 42 mod 2 is 0, right? Because it goes in 21 times, remainder 0. That's how you know it's even. When it goes in cleanly, there's nothing left over after you divide by 2. That's your remainder, right? Because 43, for example, that's an odd number. It goes in 21 times as well, but with remainder 1. And that's how you know it's odd. So like checking the result of your input mod 2. Is it 0 or 1? That'll tell you, all right? So let's say that we want to ask a question that is yes when it's even. So like we want to check if it's even. So that is this. That's this condition. Is the input mod 2 equal with 2 equal signs, right? Equal to 0. That's the question that we can ask. And that will result in true if it really was, right? If it really was, then in the true case, that was an even number. In the false case, that means it's an odd number, right? It was 1. The only other option with mod 2 is 1. So it was odd in that case. All right, and that's the secret. All right, I'm going to do a screenshot here in a second, so I'm going to move this over so there's room, but now we can code it. So we'll call it even-odd.cpp. And so let's get a number from the user. Instead of calling it input, let's call it n. Int n. Let's ask the user, hey, enter a number, please. We'll see an into the n variable. And this is now what we want to check, right? If the input mod 2 is 0, if n mod 2 is 0, then that means it went in cleanly. If that was true, it was even, right? Otherwise, it was odd. So, we want to see out even in this case, something, and then odd in the other case. Does that make sense? It's one or the other, and you could have multiple lines in here. It doesn't matter. It's just whatever you want done. It's just one thing for our current example, though. And that will do what we wanted. Boop. So enter number 42, even, 43, odd. Cool, it's one or the other, right? If this is true, then it goes down the even branch. If it's false, it skips right to the odd branch, all right? Cool. What do I want to do now? Let me take this code, and then I want to draw on it, because there are some new terms I want to give to you. And I have a feeling this blue pen color is not at all easily visible. So let's change to green. That's a little bit better. So, okay, here are some new words for you. So this question that we're asking that controls whether we go down one side or the other, that's called the condition of the if-else. That's called your condition. So condition, conditionally, we go down this side or this side, right? That's your condition. And then for a weird reason, we call the code that you run when it's true and the code that you run when it's false, we call those bodies. This is like the body of the if statement. This is the body of the else statement. You kind of think of it like a stick figure, I guess. And like here's the body, like the meat of the if is the stuff you want when it's true. Okay, so that's the body of the if, we say. It's like because you could have a bunch of code in between here and here. It's like that's where the meat is. So we call that the body. The body of the if statement. Also, I call it the true branch. So you'll hear it called the true branch as well sometimes. And then this part, we'll call it the false branch or the body of the else. Okay, so these are words that I will just say so often that you'll get used to them, all right, one way or another. But those are some new words for you. And yeah, that's if-else in a nutshell. You don't need else if you don't want it. You maybe sometimes only have something to do if a condition is true, and then you could just say if without an else, all right? So this if without an else works like this. It's like it checks the condition, of course, and then only if it's true does it run the body. Otherwise, it skips over the whole darn thing and just goes on to the rest of your straight line code, okay? So that's, you don't need an else if you just want to do nothing if it's false, all right? You don't need like an empty body, for example, for the else case. You just don't need to put it, all right? So that's that's helpful sometimes. Yeah, I think that's all that I wanted to say for that. I do want to tell you something unfortunate now, all right? This is a little weird, but it is, I promise it is slightly useful, but it'll take some time to fully understand why. But here's what C++ does with numbers. Sadly, you can do this. C++ will convert something other than true and false into true and false if you put it in a condition, including numbers, all right? It implicitly converts other values to true and false. So numbers look like this. Every number in C++ other than 0 is considered to be true, all right? C++ is like, yeah, that's true. And then the number 0 only means false to C++. So you can do this. You never should, but you could do this. You could say if 42 and then put a body. And you know what? It will run that body because 42 is true as far as C++ is concerned. Disgusting, I know. It does have its use. And then you could also, like 0 is the one false thing. So if you said if 0 and then had a body, it would not run that body. But if you put an else attached to it, it would totally run that else body. Da-da-da. That one would get run there. I know it's weird. I know it's disgusting. Please don't do this. Hold on to that feeling. So, okay, that's a thing though. So now you know. Please never do it, but that's useful knowledge, I promise. And now here's my question for you, all right? Let's just see if we're ready to keep going. So try this out in your mind. That's the best way. Don't go to code, straight to code. Try to stop and think and reason about the code just right here on the slide, all right? Try to pause the video, think about it. What do you think the following code will print? It puts 41 into an x variable, and then it does this if-else. All right, see if you can figure it out. And you can go to code after, like go run it yourself after you've thought about it though, but definitely take some time to think about it. So there's a reason I'm asking this question. It is a trick question. So you might think like, oh yeah, it's checking if x is 42. It's totally not 42. So it'll print that it was not 42. All right. Let us make a new program just for this example, because it's a weird one. It is a trick question though. All right. Did you notice it? So here is the code, and as usual, when I copy from PowerPoint, weird things happen sometimes. So like these quotes are weird. Is that the only thing that's weird? All right, pay no attention to what is underlined on my editor. It's trying to be helpful right now. There's something wrong there. Do you see it? It prints it was 42. Interesting. All right, so this is not as it seems. All right, it's not at all as it seems. Do you notice the problem? Do you see what's being underlined in my editor? It's trying to warn me about this. What's wrong with that underlined section? Do you see it? What's wrong with this condition? All right, this is back in the previous set of slides, I was paving the way for this slide right here. I hate that it's the equal sign. It should have been this, right? I told you it should have been an arrow, and here's the problem. So double equals is what it should have been, right? Double equals checks for equality, gives back true or false. Single equals is assignment, all right? So we did something very disgusting right now. So we had this. We said if x equals sign 42, which was an assignment statement, x previously held 41. Right? That was what was happening on the previous line. X held 41, then we ran this condition, right? Because that's the first thing that happens in an if else. So problem one, fact about C++ number one, you can put whatever you want as a condition, including an assignment statement. Like this is technically allowed, even though like it's not giving back true or false, all right? Okay, so it's going to try to get true or false out of this assignment statement. That's what C++'s goal is right now, because you put it there as a condition. It needs true or false. It's going to try to get it for you. So it's going to run this line. It's going to run it as a normal line, and so it's going to set x to 42, even though you didn't want that. Right? That's the first thing that's going to happen. So it's going to set x to 42, so it's going to run that assignment statement, and then also the result of an assignment statement, because it needs true or false back after this thing's done. The result of an assignment statement is whatever the right-hand side happened to be. All right, so this becomes, after setting into 42, this looks to C++ as if it were just if 42. See where I'm going with this? So the assignment statement, after it does the assignment, it results in the right-hand side. And then the if statement is like, oh, I know how to convert this to true or false. 42, it's non-zero, so that's as if you said if true. Isn't that funny? So oh man, the result of that assignment statement is the right-hand side, and so this was if true. And so what it did, right, is not only did it not check if x was 42, it made sure. It set it to 42, and then that resulted in true. All right, that resulted in true, and so it ran the body. It really was 42 at the end of the day. So you just changed x even though you didn't want to. All right, and then also, what if you did this? If x equals 0. So this would set it to 0, and then it would run the false statement, all right? So, oh man, even though you thought like if it was 0, like you'd be doing this. 0 results in false, right? And so it would run this. Even though you just set it to 0, it would also say that it was not 0, because 0 is false, and it would go straight to here. You kind of see that too? So this is horrible. This is really disgusting, and I don't like it, all right? But I have to warn you about it. So the reason this wasn't an error, again, is because sadly, the assignment statement can give you back a value. A lot of statements in C++, even though they look like they don't give back values, they do secretly, if you needed them in the situations like this, all right? The one thing you can gain from this fact, kind of the reason why this works for assignment statements, here's the one nice fact about that. You can set multiple variables at once, all right? You can say like int x comma y to declare two variables, and then you can give them both values all at the same time. You can say x equals y equals 42 to set them all to 42 at once. All right, that's the one thing you get from this fact about assignment statements. Honestly, I don't think it's a good trade, but the reason this works is because the assignment statement will draw parentheses like this, And so it'll run this part first, which sets y to 42, and then it will result in 42, and then it will go on and set x to 42 right after. So you can set a million variables all at once on the same line. That is one thing that you gain from this unfortunate fact, all right? But now you know, right? If you didn't notice this, always be watching your conditions. If you're checking for equality, double equals. You're going to run into this problem. It's going to be really hard to track down. This is like a classic case of a logic error, right? Of a bug. Very hard to track down. Okay. Yeah, so another reason why the equal sign should have been an arrow. Would have been much easier to find. Okay, so there's that. That's a problem that you know about now. Let's keep on trucking. So you can put whatever code you want within the body of an if statement or an else, right? Whatever you want here, all this stuff, arbitrary code can go here and here in addition to being other if else's, all right? So like you can have this outer if, and then you can have an inner if else inside of that. Why not? All right, so kind of, can you see what it's gonna check when it runs? So let's try to convert this code to a flowchart diagram. All right, so the very first thing it's going to do is, like, this is the outer if. It's going to start here, and it's going to check, hey, is x even? Because it needs to do that first to know, like, do I run my body or do I just skip over it? So it's going to check, hey, is x even? Is x even? Question mark. Boop. And if it's true, it does one thing. If it's false, it skips over everything. And so, like, I'll draw that in a second. But, like, let's figure out what happens if it's true, because we have some work to do. All right, so if it's true, if x is even is true, we're going to run all these bad boys. Okay? And so that's another if else. It's just more code. It's fine. So what's going to happen? Well, we're going to run this condition, right? Because if it's an if else, we have to figure out, like, do I go down this side or do I go down this side? And so it's going to check, hey, is x positive? Is x positive? Question mark. And if that's true, right? If that's true, it'll run this body and be done with it. Otherwise, it'll run the else. So do you see how if this was true, if you got to here, you got to right here, the number that you were asking about must have been both even and positive, right? That's the only way that you could have gotten here. See how I'm reading that? That's very important. It was even and positive. If those were both true, that's the only way I got to this place. It was even and plus for positive. If that was false, well, we still know that it's even to get to this check in the first place, but we know it wasn't positive. See that? So it was even, but not positive, so it was like negative or 0. All right, non-positive in that case. You see that? And so it's one side or the other, and once you've gone down one side, that's the whole entire part of the inner FL. So like the whole darn thing's done. You've hit the closing curly brace, and you're ready to go to the rest of the code. So after both of those, you go down, like you're done with everything, on to the rest of the code. If at the beginning it was not even, if that was false, then you go straight to the rest of the code. Whee! Just like that. So that's how the code's going to run, and that's what you know, right? If you went straight here, if it was false, that means it was odd. Okay? Do you see how I'm reading that? Do you think you could do that kind of drawing? Because that's proving that you understand how this code's going to run. All right? This is something I want you to get good at. That's very, very good for your computational thinking skills. All right? But that's something you can do. You can nest, we say. You can nest if-elses inside of if-elses. And that's totally fine, and it all makes sense, I hope, right? You see that you can have more things that you're checking, so more finer-grained control that way. So let's see. Do I have an example for that right now? I think I'm just going to let you think about it. I do have a more involved example that gets into that, though. All right, so let me teach you a new piece of syntax as well as show you an example of this nested thing, nested if-elses. So I want to teach you some new syntax called else if, but I want to motivate it first without it. All right, so a very common thing to do in computer science, in a program, is to have a bunch of alternatives, and you want to try the first one. You want to get at the first alternative that is true. All right, so let us do this example. Let's do abbreviations of days, because like maybe you're making a calendar program. You want to do this kind of abbreviation of days, like so that you can see it all at once, and it's nice and small. So like Monday, you want to abbreviate that as mon, right? And like Tuesday, you want to abbreviate as tu. Wednesday, you want to abbreviate as wed. So here's kind of the flowchart form of what's going to happen, right? You have to try alternatives. Like maybe you're going to get a day from the user, right? What day is it right now? And so you'll check. Hey, is the day equal to Monday? Question mark. If it is, right, then you want to abbreviate Monday and call it a day. Then you're done, right? The answer is MON in that case. But if it's false, you want to try another alternative, right? Maybe it wasn't Monday, but maybe now it's Tuesday. I'm not sure which of the other days it is. I have to try some more. I have to have more checks. Do you see that? And so that naturally leads to this kind of nested checking. So maybe, all right, maybe it's Tuesday. So let's check if day is Tuesday. If it is Tuesday, we need to abbreviate that as 2, right? I hope you can kind of understand the program. So if that's true, it's not true, it's 2, right? That's my abbreviation. And then if it's false, though, I don't know what day it is still. I just know it's not Monday or Tuesday. You see that? So it's going to be another check now. All right, maybe it was Wednesday. So day, let's check if it's Wednesday. We better wear pink if it is. And then, like, if that's true, then we're gonna, it's a bad looking arrow. If that's true, then we're gonna abbreviate that as would. Otherwise, if that's false, well, maybe it's Thursday, Friday, Saturday, or Sunday. You got more checks. Do you see that? So that's a very common pattern in programming. It's like, all right, give me the first one that works. Like, I'm just trying to match day against what day it really is. See that? So let me make that program for you, right? And the only way we know how to make this right now is with this nested if-elses. Like, all right, if it's false, I got a whole big long if-else with inner if-elses inside of it. All right, so let me show you how ugly that can get, and then I'll show you a trick. I guess I'll call this program elseif.cpp because the name of the trick is called elseif. All right. But let's do it the first normal way, the way that you can understand right now. So let's make space for the day and ask the user for what day it is, or enter just some day. Get it from CN because it's just a word, and then we're going to do this check, right? We're going to do this kind of day abbreviation. So if, I guess the first option, right, is if it's Monday. So if day is Monday, if that's true, then I would like to see out mon, right? That's the shortened version of Monday, and then I'm done, right? That's if Monday matches, like that's my job, and I'm done. I figured out the problem. Otherwise, though, if that was false, then I'm here, right? I still don't know what day it is, but I just know it's not Monday, right? I have to try other options now, other alternatives. So if we get here, we know that it wasn't Monday, and now the question is, like, what day was it? Was it Tuesday, Wednesday, So you have to just naturally, right, you have to start nesting your if-elses. So, all right, maybe day was Tuesday. If it was, see out 2, and that's my answer. If it wasn't, though, else, like, I gotta try some more options, right? I just know if I got here, then it wasn't Monday or Tuesday, right? I still don't know what day it really is. I got more checks to do, so now we're here, right? So maybe it's Wednesday, maybe it's Thursday. So let's pretend we're only going to abbreviate weekdays because this gets very tedious. All right, so let's just do up to Friday. So if day is, all right, it wasn't Monday or Tuesday, let's try Wednesday. Maybe it's Wednesday. If so, then I'll see out wed. That's the abbreviation. Otherwise, well, I just know now, right? This is getting ugly. But if I'm here, I just know it wasn't Monday, Tuesday, or Wednesday. So maybe it was Thursday. See out th as our abbreviation, if so. And then let's say that it's only up to Friday. And so if we ever get here, right? If it wasn't, right? Notice all the indentation. If it wasn't Monday, got the else. If it wasn't Tuesday, else. If it wasn't Wednesday, else. If it wasn't Thursday, else. Let's say the only other option is Friday. Let's pretend. And like in that case, we can just have an else. Fry. All right. Must have been Friday. Or the user spelled the day wrong or something. But do you see all these disgusting curly braces? Like I can't even show you all this on one page right now. There you go. It's gonna work though. Let's try it. So I'm getting a day and I'm doing all this to it. Can you kind of see how it's following this pattern? All right, and it's gonna just print one or the other, whatever day it really was, and then it's done. So enter day Monday. It's gonna print mon and be done, right? Because it's all right. This is true, so it runs this and it skips over the else, right? That's how it works. If it's Tuesday, it prints just 2 and it's done because this is false So it tries all this. And so the very first thing it does is this else. If day is Tuesday is true, it is. It prints 2, and that means it skipped over the entire else, right? Do you see how it's only going to print 2 and then it's done with everything? Same for Wednesday, Thursday, and Friday. It's going to print wed because, all right, we got to here, and, well, this was true. So it prints this part, and it skips out on all the rest. See that? It's just trying the first alternative that works. Same for Thursday, and then for Friday. All right, prints fry. It also prints fry if you misspell or like put something garbage. We're going to pretend that the user only knows how to do it right, though. So it's like this is the end of the train, right? That's the last option. Fry is always going to be what's given if none of these other ones hit. All right, but that is this. I hope you see. There is a better way. All right, this is very disgusting. It's very indented. I don't like looking at it. Let me show you the shortcut now, because it's going to correspond to this. All right, you have to see the hard way first, and then you get to learn the shortcut. All right, so this is a better way to do it, right? Wouldn't you agree? It's just like, all right, if today's Monday, then print mon. And then we want to like encode the idea of otherwise. Otherwise, if today is Tuesday, print 2. Otherwise, if today is Wednesday, print wed. Otherwise, just like the concept of otherwise kind of saves us from this nesting, doesn't it? And like otherwise at the very end, like it must have been Sunday, so like print sun or something. Like that kind of doing alternatives, like if this is not true, otherwise try this. It looks a bit different, right, to this. It's going to look different to this code. So it's called else if, all right? And here's how it works. You say if, you give your first condition as normal, like if today is Monday, print mon. And then to correspond to otherwise, in C++, you say else and if right after each other. You say else if, read it as otherwise though. Else if, then you give your new condition. Else if day is Tuesday, print 2. See that? And then it will run that body if it works out. And then if you have another option, like otherwise, else if that one didn't work, if today's Wednesday, try and print wed. All the way down. Right? You can have a bunch of else ifs, and those all mean otherwise. Otherwise, if this condition is true, because the other ones weren't, run the body. And then you can have one final at the end, else. If nothing worked, if nothing at all worked, then here's like your catch-all down at the bottom. Then try this thing, all right? So read else if as otherwise, and let me show you how to translate this code into the equivalent code that uses else if. All right, it's gonna look a lot cleaner. Let's start with this code though. Boop. And then watch how much cleaner it gets. So, all right, the first step is normal. It's the same. If today's Monday, that's our first option, right? Print mon. And then it becomes otherwise if today is Tuesday, right? Else if otherwise. And so here's what you do. You say else if today was Tuesday, print 2. See that? Unindent. It's cleaner. Otherwise, else if today was Wednesday, print wed. Just give me the first one that works, please. Else if today was Thursday, print the. See, I'm getting rid of all this indentation now. Print the, because it was Thursday. Otherwise, else, print Friday. Because like that's your only other option, let's say. And then I can get rid of all these other braces. This is equivalent. This code is exactly equivalent to what I just wrote. Which one do you prefer? Well, you had to learn it the hard way, I would say, to like understand like why this is nice and like what it really corresponds to, because it's going to do the exact same checks. It's just like this is shorthand, all right? But you read else if as otherwise. Like if today's Monday, then print mon, and you're done with everybody. Don't like it's just the first one that works. You only go down one of these bodies. Just the first one that works. Otherwise, if today is Tuesday, print 2. Otherwise, if today's Wednesday, print wed. Otherwise, if today's Thursday, print the. Otherwise, that's our catch-all. It must have been Friday. So it's going to print the same thing twice now because it's running this. These two pieces of code are equivalent, and they're right next to each other. It's like Monday, mon, right? It still works. It's like this one, and then it's done because none of the otherwises get to run. Just like the first one that works, and Monday worked. So it prints 2 twice. One from this one up here, and then like, all right, okay, this was false, so we did this one. Otherwise, if this is Tuesday, yes it was, print 2, and then I'm done. Bam. And then same for Wednesday. I think you can understand that Thursday's gonna work, and then Friday is Fry. All right, all the way down here. All these fail. This is our catch-all, right? And it prints Friday. So do your best to stare at this code for a while, because I know it doesn't sink in the second I talk about it. This is going to take some thought, but like try to understand why this corresponds exactly to this code. All right, you're going to read about this in your book as well. It's very, very useful stuff. So else if, you're going to grow to love it. All right, I hope you can see the savings that you get from it. All right, and so I want you to try. I want you to try now. So try to practice this pattern with our else ifs and our otherwises. I'll give you this code to look at while you try it, but this is a great test for you. All right, here's your reference. I'll put it in the corner here. Here's what I want you to try. All right, write some code to do the following. Get a get a number from the user that's like a percentage, like it's somebody's grade. All right, grade in the class, and put it into a double variable because grades can have like decimals, right? And what I want you to do is print the following, right? Let's pretend that this class is a weird class, and you can only score an A, C, or an F in the class. All right, so print out C based on this grade variable if it's between 70 and 89.9999 on forever is just smaller than 90, right? So C if this is the grade, and F if the grade is less than 70. This is a very strict class that we're pretending to be in. And then an A as the grade if it's greater than or equal to 90, all right? I claim that there is a way to use if, else ifs, and elses to print out these letter grades, just one of them, based on a grade variable using these exact conditions. But you'll have to mess up the order of them, all right? This current order is not going to do it right. So you'll have to rearrange them to make it work. But I claim that there's a way. See if you can figure it out using else ifs as well. So like this is code that's running in Canvas, for example. Somebody coded this kind of idea up in Canvas because it shows you your grade as a letter based on a percentage. So this is a good example, I think. All right, did you see how you'll have to jumble these guys, reorder them? Because the original order is not going to work. Do you see why? So let me show you. Let's see here. So I want to get a grade from the user as a double. Colon space. And so now I got that grade, and I want to convert grade to A, C, or F based on the criteria here. All right, and so there's a way to do it. Unfortunately, this order is not going to work. So like let's do this order. So like if grade is greater than or equal to 70, we'll do 70.0 because it's doubles, why not? Then we'll like see out C line. Otherwise, else if it's less than 70, then it's a F, sadly. And then otherwise, you don't need an else at the end. If you have a bunch of conditions, you can just have a bunch of otherwises. Otherwise, if grade is greater than or equal to 90, then it's an A. So this code will work for some of the grades, but not all of them. Do you see why? Did you draw a picture? Did you try some examples? Highly encourage it. But all right, let's say that our grade is 75, for example. So it is correctly going to print C there. And if the grade is like 65, it will correctly print F, but it will never do A right. Do you see why? It'll never get to A. This body will never run. Think about why. If I say 95, for example, it prints C. It's stuck here, right? 90 exactly. Still prints C. 100, it prints C. Why is it going here? Well, think about how this is running, right? It's picking the first one that works. If the grade is 90 or 100, is it greater than or equal to 70? Well, of course it is. So it's going to go here and skip out everybody else. See the problem? So that means, like, if A is the one that's hardest to get, that should have been the first condition you checked. You see that? That's what needs to happen first. That's the rearrangement. I hope you see that. So if I do it this way, 90A, 70C, technically this will work, I think. So we got like 95, so it hits the A part, perfect. And do you see how it works for like 89.999 properly? Because it's like, all right, it wasn't greater than or equal to 90, so it's not this one. It wasn't less than 70. It's like the only other option is it's greater than or equal to 70, like if we hit this one. And then also, it must have been strictly smaller than 90, because otherwise this one would have fired. See that? It's like that's how you know it's going to work for C. And so there is a better arrangement, I would say. There's a way to do it without a bunch of else ifs. There's a way to do it with if, else if, and else. It'll be this way. Because I can do this. you don't actually need the one to check if it's 70. Because, watch. Do you see how, if this is not true, if it's false, it must have been less than 70. That's the only other option, right? It's not greater than or equal to, it must have been less than. So like that, you don't even need to encode it, all right? The opposite of greater than or equal to 70 is less than 70. So technically, you don't even need this. So do you see it? I hope you do. And so I think this would be the cleanest way to write this code. If it's greater than or equal to 90, it's an A. Or exactly equal to 90, right? It's an A. Otherwise, right? Otherwise, if it wasn't greater than or equal to 90, it must have been less than that. Otherwise, if it was less than 90 and then it was bigger than this, right? Greater than or equal to 70, 70 or bigger, 70, 70, 1.25. It's going to run this one and skip over anything else. And then our last one, else. Otherwise, if none of that's true, don't even need a condition anymore because of what we're checking. Otherwise, it must have been less than. Must have been less than 70, so like 68 or something, automatically an F. All right, I hope you see that. Do yell at me if you have any questions about this, but that I think is a good example to kind of show it to you. Another good exercise for you to try on your own is to do one for normal classes, A, B, C, D, and F. You see how you can make this bigger based on that? Give that a try. Let's see here. All right, so I think we're ready for one last topic for the day. I want to teach you about a new type in C++. It's called the bool type. That's super cool. It's short for Boolean, and I've said that word before, haven't I? I said the word Boolean expression, and I never really told you what that meant. Well, first of all, this is named after somebody. I think his name was George Boole, and he invented the idea of trues and falses and math on them. So that's why we have this word based on his name. But Boolean, becomes in C++ a type called bool. All right, and so the bool type is very small. It's a very small cloud. All right, so the int type, for example, it had a bunch of things in it. Right, it had every whole number in it. It had like 42, 0, -40, all those things. The bool type is a new type in C++. And it only has two things. It's a very tiny cloud. It has just true and false. So you can put in a variable the ideas of true and false now. All right? You have a type now to hold on to that stuff. You can put any Boolean valued expression, which means anything that you could ever put in a condition of an if statement, for example. All those things, like these guys too, they can go into a bool variable. All right? Just like in a condition, and it will evaluate to either true or false, and then you can shove that into a variable. For example, it might look a little weird as you're first seeing it, but you can do this. You can say like bool b, it's the name of a variable now, equals the result of checking is 42 less than 43, right? Because this code's going to give back true or false, isn't it? It's like, all right, what is b going to hold now? It's going to hold true, right? Because 42 is less than 43. And then you can condition based on that. You can be like if b, and then run a body. And this will run the body, won't it? Because, all right, this will just check if the if statement checks if the thing in its condition is true or not. And this b, it is true. It's holding true. So it just gets replaced with what it's holding. And like, all right, it's checking if it's true. And so it really is. It will run the body. See that? So you can do it in a two-step process now. You can make a complicated condition and then just like put that in the if statement as its name. That might be helpful one day. All right? I hope that makes sense. Let me show you that in some code. You'd be like bool b1 equals, hey, is 42 less than 43? So that will hold true, right? Let's do a few more. Be like bool b2 is 45 greater than or equal to 55? That one will hold false, won't it? Then you can also hard code them. Be like bool b3 equals true, b4 equals false. Like you can do it just once and for all if you want to. And then one interesting fact of C++ is cout, by default, you can change this, and you can also make your own if statement to do it yourself. But when you print a bool value as just in C++, it will sadly print it as a number, which is very odd, I know. What's going to happen is it'll print 1 if it's true and 0 if it's false. So it just converts it to a number by default for a weird reason. So b1, even though it's a bool variable and it holds true, this one really holds true right now, it'll print it as a 1. It's like the binary equivalent of true, essentially. And then b2, that was false, right? Because 45 was not bigger than or equal to 55. that prints 0 because it was false. All right, so just keep that in mind. You could, of course, do this yourself with if statements. You can be like, all right, if B1 is true, cout B1 was true. Like you can print true or false yourself with an if statement, can't you? I do want to say though, and this will print that because it will run the body because B1 was true, was the same. I do want to convince you that this is the better syntax. This equals true is redundant because this is exactly the same, isn't it? Because like the if statement is just going to see like, is the thing in the body, is the thing in the condition true or false? What is B1? I'll just go look it up, replace it with what's there. It's as if you because B1 holds true, it's as if you did this, if true, because of that. Does that make sense? I'm just going to replace this with whatever B1 holds, and like the if statement runs the body. If this results in true, it is itself true, and so it will run. All right, so you didn't need the equals true. That's redundant. All right, that will take time to fully sink in, but I just want to say that once now. I'll keep saying it. So it was true. This just results in true. All right, so kind of when I see this in code, somebody else wrote it, I'll read it as like if B1 was true. Right, I have that in the back of my mind because that's how if statements work. This only gets run if this was true. All right, and then you can of course do it in an if else as well, because like B2, that holds false right now, doesn't it? It's like if B2 is true, cout B2 is true, and then else, right? Else otherwise, maybe it was false, and it was false. So it'll hit the else case, the false branch, the body of the else. See that? So yeah, I think that's what I wanted to say about bools. There's one last thing that's going to help us make more complicated conditions. I want to show you a new operator. It's called AND. All right, there's more than just this one. This one's called and here is the secret. All right, you know that you can do this. You can check if something and something else is true by nesting. You can be like, all right, if num mod 2 is equal to 0, that means it's even if you're in the body, right? It's even if you're in the body, and then you can check another thing. Like if num is greater than 0, then you do this part, right? If they're both true, the only way that you got here, right, is if both conditions were true, and you know then, you know that if you got into here, it must have been even and positive, right? That's checking both at the same time. That is a lot of work though. So there's a new operation that you could use on your Boolean values, your trues and falses. It's called and. It's 2 ampersands, 2 ampersand signs. And here's the equivalent. You can do the same thing like this. These two are equivalent pieces of code. You can give both of them at once. You can say the first condition, if num mod 2 is equal to 0, and then you can put this sign, and, meaning and then you can put the other condition, num is greater than 0, and you read it like this. If num mod 2 is 0 and num itself is greater than 0. It's checking both of them at the same time. They both have to be true for this body to be run. Like, only if it's even and positive will this part get hit. All right, so that's what it means. That's what and means, just like normal and in English, right? And so just to spell that out, there are things that we use, because we'll have more complicated condition combinators one day, next time at least. I want to show you what's called a truth table for this operation. The truth table for and looks like this. So here's a big long table of all the options that the and operation can give you back. Okay, so B1 anded with B2, we say, is true only if B1 is true and B2 is true, which is just like logical, right? Like it's checking, hey, is B1 and B2 all true? Are they both true? It's the only case, right? Here are all the options. There's 4 different options of your variables. Like maybe you can think of B1 as positive and B2 as if it was even. The only way for their and to be true is if they were both individually true. Do you see that? Because like any other way, like if B1 was true but B2 is false, it's not correct, right? It's false to say like, oh, B1 and B2 are true, right? Because B2 is false in that case. I hope that makes sense, right? So it's like you're lying. Like, hey, is B1 and B2 true? Is false and true? Is it positive and even if it's not positive, but it is even? No, false, right? And of course, it's not positive and even if it's not positive and not even, right? Their and is false. So the only way for it to be positive and even is for it to be individually positive and individually even. Okay, so again, that's another kind of concept that does take a while to sink in. You'll read about it in your book. You'll do some exercises. I'll force you to use it. But that's the AND operation. Honestly, I think it makes more sense in an example like this, right? Just like AND only makes sense if they're both true. Like it only is going to run if both of those sides was true. And that's kind of what this diagram is trying to say, what this truth table is trying to say. So yeah, for my last trick, let me just code all that up so you can see it. Let's write out the truth table in code. So is what's true ANDed with true? This is the only one that's going to be true, right? Only this one is true. Let's do all the other options. Cout true ANDed with false. False ANDed with true. And false ANDed with false. So remember that it prints it out as 1 or a 0. And so it's going to be 1, 0, 0, 0, because the only way that it's true is if they're both true. True ANDed with true, that's the only thing that's true. All right? It results in an overall final answer of true. Whereas the rest of these, like, are true and false true? No. Are false and true both true? No. Are false and false true? Definitely not. All right? So that's kind of how you read it. Again, I know that the first time you see this and hear about it makes not a lot of sense. So I have more examples, but this is where I want to stop today. Do study this one. Yell at me in office hours. Ask me questions on Discord. I am here to help. But I think that's where I would like to end the day. So you've learned about a new type of way to combine things, right? There's more than just and. This implies the existence of or, which we'll get into next time. All right? And I'll also show you another example just to remind you and try to get and in your brain. So I think that's where I want to stop today, and I will see you in the next one.